So today's Friday. We're going to wrap up Unit 11. Um, Typical to a Friday, we'll do some review exercises and problems today. I'll probably spend like the first half hour walking you through one of the review problems. And then the second half of class, I'll let you have time to work on a review problem, or if you haven't finished the pesky tourist problem from last week, do that. If you're still working on the Conway Life stuff from Wednesday, you can work on that, or we'll look at the assignment, and I'll give you a brief introduction to the assignment then. But I'm going to start by looking at some of the practice problems, and maybe we'll pick one of those to do here. And so again, we're trying to do problems that involve arrays and often multiple arrays or multiple dimensional arrays for this stuff. So let's see, we've got this wide receiver rating one. We've got a golf score one where we have multiple team members here. We've got keeping track of a deck of cards, keeping track or searching through a list of Pokemon here, and then trying to play Powerball and see if you are winning for that. I think in this class, I'm just going to walk through a little bit of the wide receiver one and just kind of see if we can visualize that here. So I'm going to just start with the initial code for this, and then create a project to do this with. Hey. So I'm going to take some of these classes here and just copy them into this code project I just created. And we'll look at that a little bit. So in American football, there's a position called a wide receiver, and they catch the ball that's thrown by the quarterback, and we have stats on them. And people play fantasy versions of these football games where they generate stats, or they use stats based on other games, and they run whole leagues and stuff with this. So this is a game kind of related to this. We're going to have a bunch of wide receivers that we can look at, and we're going to look at the stats for them, and then try to rate wide receivers, trying to figure out which is the best wide receiver out there for this. Well, I have to do one more import, it looks like here. So this basic game, if I run this, it generates a list of wide receivers, their names, and then some information about them. So there's three numbers: the number of receptions they've had, the number of yards, so how far total they've had for receptions, and then how many receptions they've had for touchdowns here. And again, this is all made up data. I think the wide receivers are all real, but probably a few years old. But again, I can look at one of these people, Adam. He's got 80 receptions so far this season for a total of 1,229 yards and 7 touchdowns here. So that's what we have. So what are we going to do with this? So we run the code. It should display the stats on 30 different wide receivers in our fantasy football league. The code keeps track of, the number of receptions, the number of yards, receiving yards, the number of touchdowns. We need to determine a method to assign a score for each player. This should involve combining the three attributes in some way for this. We want to declare an array to hold these scores for each receiver. So let's do that here. So right now we have a two-dimensional array for this for each receiver or for all the wide receivers. And we're going to make a new array. I guess I'm going to do an integer array. You could do a floating point array. And I want to be some sort of score or value for each wide receiver there. So I'm just going to call it score. Oops. Remembered how to declare this in Java. I say int brackets score. Let me kick that up a little bit. Equals new int. And then how big should this array be? So I'm gonna, I think it says there's 30, so maybe I could just put 30 in here to start with 30 scores for this. I'm not quite sure, but we also have this, we have the array of all the names of the wide receivers here. And so, and our loop loops through that. So I could actually use that length as the size of the array. So I assume that's 30, but again, I haven't counted. So I'm just going to use the size of this array for that. Now I'm going to assign some value for each wide receiver. And here's my loop to print out all the wide receivers. I want to do something similar. So I'm actually going to copy this loop and do it ahead of time here. And for each wide receiver, I'm going to assign their score sub I. Each receiver will be getting a new score equals. And somehow I want to figure out their score here. So like one thing I could do is just add up the receptions plus their yards plus their touchdowns. That'd be a nice simple way of doing it. And probably not accurate because the number of yards is a really big number. But for starters, I could use that. So I'm just going to add up the number of receptions plus the number of yards plus the number of maybe I'll skip the number of yards for now. Maybe I'll just do the number of receptions and the number of touchdowns. Here. So how would I do that? So here I'm going through I have a loop with an index I, and I'm going through, I want to get the receiver's receptions here. I can look back. So the yards, the receptions are here. How is that stored in the computer? So I have a two-dimensional array here, and wide receivers sub 0. So again, this is stored kind of in a table. So this is like the 0th column, the first column, and the second column. So I want to get the 0th column, and then I want to get the corresponding receiver. So if I want to get this would be the 0th column and the 4th receiver down. So again, that's what this is kind of showing. Wide receiver, sub 0, and then the player number. So again, here I could say I want to get my wide receiver data. And I'm going to do 0 as the receptions. And then for the player, I'm just going to use I, which is my counter. So score for the ith player is going to be that. And I'm going to add wide receiver data. I'm going to add in the touchdowns, which is, again, that's the 0, 1, 2, the second column. So the first number here is the second column, and then the receiver, the player is the ith player. So does this make sense? This statement where that this adds up the number of receptions. Basically, I want to add up the number of receptions plus the touchdowns for each player. Now I want to print that out here for this. Let's look at how the printout works here. This looks like a weird printout. So remember, we've seen printf before. It's for formatting. And so we're formatting strings with 25 spaces. And then D, if you remember, D's are integers. A D for 15 spaces, another integer for 15 spaces, another integer. So I have to provide a string, the receiver's name, and then the data for each wide receiver here. I'm going to add in the score for this. So I'm going to add in the score. And that would just be the variable score sub I. But then to do that, I need that to show up in here. So I've got another, and maybe I'll put in some spaces so we can see this a little better. I'm just going to try the same thing, minus 15D. And see how that works. Let's see if that'll print out if I get an error. Now I'm getting an error for that format here. I think I'm missing a still getting an error with my formatting. Following error occurred while executing this line. I'm going to back up these changes. Okay. Go back here where it was running again and try again. Okay. So yeah, so here's what I want to do. I want to do a percent dash 15. So I want to do another percent dash 15D here. And then I want to put in the score. So here's my score for each one. And again, it's going to be the number of receptions plus the number of touchdowns is some sort of score for it. I want to put the word score above it. And so here I'm printing out, where do I do that? So this loop prints out all the information, and this loop prints out the headings. So I'm going to add that to this. And here each one is a string. Here, maybe let me try again to put in some spaces in here so that this looks a little more readable. So here I'm printing off someone's name with 25 spaces, the word receiver with 15 and 15 and 15 here. And then here's the words I'm printing out. I'm going to add score to this and add another one of these percent dash 15 or minus 15s here to get the score to show up. I'm not going to spend too much time on the formatting because you could actually do this without that formatting, just with print lines. It might not look quite so nice, but you can do that. But now I have the score here. So now I have a basic score, but the question would be, what would be a good score if I wanted to rate some players based on this? So does anyone follow football, American football here? No American football fans here. So, okay. So let's just try one more thing. One thing I would do just from a data point of view is I would like to keep all these numbers about the same here. So if I'm just adding them up, the touchdowns are not are a smaller number, but they seem to be important here compared to this. They seem to be, like this is almost 100 here, and this is only 2 or 1 here. So maybe I would want to make the number of touchdowns a larger number here. So the question is, how large? Should I multiply it by 10 and add it into this? Should I want to have some factor for how much more important is that number to make it on par with this number over here? Because possibly if I look at someone that doesn't have as many yards but has a lot of touchdowns, that should be pretty similar maybe to someone who has more yards but not as many touchdowns, because the touchdowns are important. So maybe I would change this so I take the number of touchdowns times some value, maybe times 20 or times 50. And that would be, I'd have to figure out what sort of value, and I could try different values, and people would have arguments about what different values are. And I could run this. And then I get some arbitrary score for every player here, every wide receiver. Okay. I'm gonna leave this here. And let's go back and talk a little bit about the assignment this week and get you started on that. And then we'll give you some time to work on different things here. So the assignment this week is image stacking. So again, we're taking pictures and we're doing astronomical pictures out there. So based on a telescope, although you can just do it even with a camera. I don't know, has anyone taken photos? Have everyone taken photos like we had the Northern Lights this past year? Did you take any photos of those? Do you ever take nighttime photos with your iPhone or anything like that of the stars? You need to take more photos of the stars, right? The stars are cool here. So the iPhone and the Android phones, they both have a nighttime photo setting. And what it does is similar to this. It takes like 10 pictures of the sky and puts them then all together to make a brighter picture. So your phone can actually take better pictures, enhanced pictures of the night sky than you can actually see. Last month, there was did anyone see the comet last month? There was the comet out last month, just on the horizon at sunset. But again, it was hard to see with your naked eye. But if you took a picture of it with your phone, just as it was getting dark, that showed up really well for that. So, but again, these are actually NASA images taken from a telescope. But the same thing, we take a bunch of images and we put them together. One of the problems, especially with Earth-based telescopes, is that each picture is fuzzy there because we don't have that good of resolution. And also things are moving a little bit and we've got some turbulence in the air, stuff like that. So we have a bunch of these fuzzy images here. Oops. That we're looking at. See how fuzzy these are? And we put them together, we're going to make one higher quality clear images. So from all these NASA images, we're going to get one clear image here. So we've got to open up this program so you can download this. Make sure if you download it, it'll take a bit, and then you go and unzip it and then open it up in NetBeans. Or we can just do the GitHub. If I click on it, grab that URL, and then over here, I go team git clone. And again, if team git isn't there, make sure you're not on a project that is already git or already cloned. So team git clone, paste in the URL there, and then copy that. And I'll ask you if you want to open it up. Once you download it, it takes a while to download because the images are pretty big. I'll just warn you there. So it's cloning it here. And it's also downloading it here. Both of them are taking a while because of how big this image is. So again, once you get the image, the zip file, you should unzip it. So I clicked on it and I actually want to go back here because I want to unzip it. So I want to go to downloads, find the zipped image and extract it. And then open that up. Oops, this one's already open. I'm just going to open this one up, I guess. Okay, where's my image stacker? So it should be called image stacker. And you should be able to go and find, there's this one Java program that you want to open up. I want that up here. So what it tells us is that it should run by default. It should show one of the fuzzy images followed by one of the completed image. But initially the complete image is black because you haven't done your job yet. So if I run this, it brings up this little box here. See this little box? And this lets me choose the folder. There's different types of images. So I hit browse. And I go into the NASA noisy images, and then there's these folders. I don't go into these folders. I just pick one of these folders and hit open. So again, just go inside NASA images, click on one of these folders. Don't go inside the folders. Don't go like that because there's nothing there. Go back up. Just pick one of these folders and hit open. Okay, and then you can hit process. And this will show again, up here, it shows one of the original images. See how grainy that is? And now it'll show the picture of the clear image. Okay, and that's all black because we haven't done that yet. And then I can quit this. If I click on the box here, I'll quit that. Okay. So we have got to go through here. We're going to work just we're not going to modify anything below main here. We're just going to modify this average pixel value. And we're given an array of images, a two-dimensional array of images here. So again, there's a bunch of pixels, and then we have a bunch of layers for this. So this isn't two-dimensional like the grid, but this is every pixel, and the first one is the first dimension is the image number, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the second is the pixels here. So we declare a variable for the number of layers here, and then we also have variable for the number of pixels. There's about 2 million pixels in each image here. And then we declare the array of averages, and it starts off as all zeros, and that's what we return. We're going to set up that array of averages. Here's your instructions. Here, we want to calculate the average of multiple layers here. So why don't you look at this a little bit and see if this makes sense to you? What would you do? Can you even, can you even figure out like how you do just one of the, or, simple average or something like that? So look at this and see. When I get a new problem like this, I often struggle with just understanding what the data is or what am I even supposed to do here. So I can read the instruction sum. So this method, we're looking at the average pixel. This method takes a two-dimensional array of pixels. You'll notice that each image provided contains 10 images. This two-dimensional array contains the array of pixels. The pixel value for the first images are all in image 0. The pixel value for the second image are in image 1, and so on. So let's see if I can understand that. So I have this array of images here. And so I can look at, let's say if I just want to get the first image sub 0 is the first image. And then I would want to do what pixel I would want. So if I want to do pixel like 450, I would do pixel 450. So I think that's what I have to get used to, is that I'd say image 0 and pixel 450. Or if I want to do the second image, because again, we've got, if I look into this, let's see, where is this at? If I look at this, there are different images. So here's my first image. Here's my second image. So we have different images here. That are available. So again, this would be the 0th image, and if I wanted the first image or the second image, and then this is the pixel number. So I have a loop already here for the pixel index. So I'm going to use that here as the pixel number. And so if I want to just add up the 0th, get the 0th one, if I say average equals that would just get the first pixel of each one. But I actually have averages as an array. I'm going to use that. Averages sub. Now, it has pixels too, so I'm going to use the same pixel index here. So averages of pixel index equals images. It should be images sub 0. So if I just did that, averages of pixel image equals image sub 0, that should just copy image 0 over there. If I wanted to copy the third image, I could do image 3, copy that over. So now if I run this, again, I get this. I want to select one of these folders, go into NASA noisy images, select one of these folders, hit open. Let's see, seems to be stuck. Oh, I didn't hit process there. So that's the first image. And then this is supposed to be the refined image, but now it's just another one. It just copied one of the images over. So again, if I wanted to copy, let's say you do the average of 2 layers, I could do, how do I do average? Well, first I'd have to add up that pixel value plus this pixel value. What if I just added the sum of those two pixel values like that? What would that do? I don't know what that does. Process. So here's the first one. And now I get an error. Color parameter outside expected range of blue. So my value got too big, or yeah, outside the range. So I did something wrong here. So again, I can't just add up these two images. I need to do the average. So I could do the add up the two and divide by 2 and try that. So again, browse, find one of my folders, open it up, process. So there's this is the original one. Hit okay. And this is supposed to be a clearer one. Is that a little clearer? I don't know. But again, I'm only adding up 2 layers and there are 10. I want to add up 10 layers and do this. And I probably want to do that in a loop or something like that. So that's what you're going to be trying to do, is something like this, more of this. Questions on this? Okay, I'm going to let you work on things. So again, for the rest of the class, feel free, again, if you never got done with the pesky tourist, you might want to finish that up or ask me about that. You can still work if you're still liking to play with Conway Life, or didn't get that right up done, do that. There are more practice problems you can do here. Or again, you can work on this image stacker. So any of those should be fine.